All right. Here we go. Advanced Math 8. We've got lesson 5.2.1, Sequences, Part 2. So what we're going to do is we're going to take those, I don't know how many there were. There are like 10 sequences that we're doing on the last part. And we're going to graph them. Now, these are going to be a little bit different because we're going to graph them. Remember when we had a sequence like A was -4, -1, 2, and 5. ... So what we saw here is how are we going to graph this if we're only given one number? Because we need an X and we need a Y in order to graph it. Well, what we're going to do is we're going to add something that's not in the sequence, and we're going to call it the term number. So the first term in our sequence, we're going to call the first term. So this is going to be term number 1. This will be term number 2, term number 3, term number 4, and so on and so forth. So whatever our first term in the sequence, that's what we're going to label it. So this is going to be like our X. And then this is going to be the term value down here. And that's going to be our Y in our graphs. So these are a little bit different than we've done before, again, because the actual sequence only has one of our values that we graph from. It only has the Y value. And so we have to make up the X value. The X value is going to be which term it is in the sequence. So -4 is the first term in the sequence, -1 would be the second term, 2 would be the third term, 5 would be the fourth term. Now before we go forward, should these graphs be discrete or continuous? Well, remember with discrete or continuous, we have to ask ourselves in the situation, can I have fractions or do I only need integer values or positive whole numbers or negative whole numbers? So in this case, because of it being term 1, 2, 3, and 4, there's no term 1.5 or term 2.7. It just goes in integer values between each term. So we'd have to say that these are going to be discrete. Because sequence numbers so term numbers are term numbers are only positive integers. So our lowest term number is always going to be first term. We're never going to have a negative term. We're never going to have a term 1.2 or something like that. So we would say this should probably stay discrete. All right, so I want you to graph. Now you have these beautiful graphs here. And I have no idea why they're so huge, but that's what we're going to deal with. So you got these big old graphs. And I want you to graph as many terms of the sequence. Now remember, there's no zero term. So all of our terms are going to start with term number 1 and then whatever that value is. So if this were the A1, I'd say, okay, the term number is 1 and the term value is -4. So that'd be my first point for A. So I've already done all these because I'm ahead of the game. So let's look at what we get for each of those terms. Now here's sequence A. Again, sequence A would be -4, -1, 2, and 5. Okay, so my first term's -4, so I go down here. First term, -4. Second term, -1. Third term, 2. Fourth term, 5. Fifth term, 8. Sixth term, we would get 11. And then we could find our next term after that, because remember we are adding 3 each time, so our 7th term would be 14. So in this case, we were adding each time for our sequence. And what we notice here is it is making a line. Part B, that's the one that had 1.5, 3, 6, 12. And we were saying on this one, oh, we're multiplying by 2 each time. So if I put my first term in there, my first term was 1.5. My second term was 3. Next term is 6. Fourth term was 12. And then following this pattern, the next term would be 24. And then way off our graph up here is 48. So we see here that when we're multiplying, we get a nice little curve going there. Instead of, on the previous one we were adding, we're getting a line. On part C, we had perfect squares on this one. So 0 squared was 0, 1 squared was 1, 2 squared was 4, 3 squared was 9, and so on and so forth. So plugging those in, I get a curve. It's a slightly different type of curve that we're going to see that later. But anyways, I get a curve here at term 0 or term 1. I get 0. Term 2 is 1. Term 3 is 4. Term 4 is 16. Term 5 would be 9. Then term 5 would be 16. And then term 6 would be 25. The next term would be 49. That would be way off of our graph, so it wouldn't fit. So there's our terms there. And what we can see here is that it's not linear. So far, we've seen that when we are adding, we get linear. When we're multiplying, we get curves. And in this case, we were taking squares, which is kind of like multiplying. We get a curve going right there. So there's A, B, and C. All right, next one. D, E, and F. All right, so D started off with 2, 3.5, and then 5, 6.5. And we were saying on this one that we're adding by 1.5 each time. Now we should expect it to be linear since we are adding 1.5 each time. So the first one was at 1, or the first term was 2, second term was 3.5, third term 5, fourth term was 6.5, and then if you keep on adding 1.5, you get new terms. So the fifth term would be 8, and the sixth term would be 9.5. We get a nice linear graph there because we're adding the same number each time. For E, the terms were, this was the Fibonacci one. So 1, 1, 2, 3, 5, 8, ... And we knew that this was the one where you're adding the previous two numbers. So the next one after this one would be 13, because I'm adding the 8 and the 5. And then the next one would be adding the 8 and the 13, which would be 21. So there is our Fibonacci numbers. And this one gives us kind of our weirdest graph ever, because here we have two terms that are exactly the same. It's kind of a curve and kind of a line and kind of really weird. All right, so it doesn't really fit anything else that we've done so far. F. We've got in this one 9, 7, 5, and our fourth term is 3, ... And we said on this one that we were subtracting 2 each time. So the next one after this would be 1 and then -1. So on this one, we also get a line. It's subtracting, and we said subtracting is the same thing as adding a negative number. So again, we're getting a linear association between these. So at 1, we had 9, second term was 7, third term was 5, fourth term was 3, fifth term would have been 1, sixth term would have been -1, and if we went on to the seventh term, we would have been down here at -3. Oh, that's the bell. Does that mean I get to go home? No. Still have to do another video today. All right, G. So this is 48, 24, 12, and then it stopped from there. But we saw on G that we're dividing by 2 each time. So after this, we should get a number of 6, and then 3, and then 1.5, and so on and so forth. So our first number is completely off the graph. It's up here, 1. Our first term is 48. Our second term is 24. Third term is 12. Then 6. Then 3. Then half of 3 is 1.5. Half of 1.5 is 0.75. Again, we're getting that curve action going there because this is division. And remember, if you're dividing by 2, that's the same thing as multiplying by 1/2. So we're getting this exponential function going on here. Next one is H. For H, we were dividing by 3 because we started off with 27. Then we got 9. Then we got 3. Then we got 1. And then the pattern went forever. And if I kept on dividing by 3 here, I'd have 1/3 next. And then 1/3 divided by 3 is 1/9. I get 1/27th and keep on going there. Again, we're dividing by 3, so we're expecting to see that curve, and we do. First term is 27 up here. Second term was 9. Third term was 3. Fourth term was 1. And then we got 1/3, 1/9, and 1/27th would be way down there. So we get a nice little curve. Almost there. I was where we were adding 4 to the differences. So this one is 8, 2, 0, 2, 8, 18. And this was a lot different from all of us because we saw that these were sometimes subtracting, sometimes adding. But we noticed that the difference between them was always increasing by 4. So here, the difference between these two was 10. So the next difference we saw would have been increasing by 4, and we would have gotten 14 as the next difference. So our next number would be like 32. So on this one, we get this graph where the first term is 8, then 2, third term 0, and then it starts going back up each time because our difference was always increasing by 4. The next one, we'd increase the difference by 4 and add 18 and get 50 on the next one. All right, our final graph is J. Okay, on J, we had 5/4, which is 1.25, 5/2, which is 2.5, and then we had 5 and 10. And we saw here we're just multiplying by 2, so the next one would be 20, and then 40 after that. So graphing that one, here's 1.25. Second term is 2.5. Third term would be 5. Fourth is 10. Then we jump to 20. And then all the way up here, we jump to 40. And then the next term would be off the graph at 80 because we're multiplying by 2 each time. All right, so what have we noticed? We've noticed that adding and subtracting always gives us a linear graph. So you probably need to reorder your families if you didn't order them like that. So anytime you add or subtract, you saw that that was a linear relationship. And when we multiplied or divided, we saw that that one was exponential. It was a curve. All right, 5-43 says when a sequence generator adds or subtracts, so when it makes a line, and so when it adds or subtracts a number, so a constant, to each previous term, the sequence is called arithmetic. So any of these that were adding or subtracting each time are arithmetic sequences. So our arithmetic sequences were A, which was -4, -1, 2, 5, ... That one was. Next one was D, which was 2, 3.5, 5, 6.5. We saw that one was adding 1.5 each time, so that's arithmetic. The next one was F. F was subtracting 2 each time, so it went from 9 to 7 to 5 to 3, and then it went ... So those would be our arithmetic sequences because we're adding or subtracting some number to the previous term to get the next term. When a sequence generator is multiplying or dividing a constant to each previous term, the sequence is called geometric. Okay, so we had 4 geometric sequences. B was geometric. This is the one that went 1.5, and then 3, 6, 12. And we saw here that we were multiplying by 2 each time. So that's a geometric sequence because we multiply the previous term to get to the next term. And we're multiplying by a constant, meaning it's the same each time that we're multiplying. Now there was one where we were adding, I forgot to mention this. In this case, we were adding 4 more to the differences, but the actual differences were not the same. The difference of the difference was the same. So this is not linear, and we saw that this one was the one that kind of curved up and down. So we can only add or subtract the same number each time. We can't add or subtract a different number each time to be arithmetic. Okay, back to this one. Our next one for geometric sequences was G, and that one was the one that started at 48 and then went to 24 and then 12. And this is the one that was dividing by 2 each time. H started at 27, then went down to 9, then 3, then 1. This is the one that was dividing by 3 each time, so that's geometric. And then our last one was J. This one started at 5/4, then went to 5/2, then to 5, then to 10. This is the one that was multiplying by 2 each time. So, arithmetic, we're adding or subtracting each time. Geometric, we're multiplying each time to get to the next number. All right, that's all I got for you. Math hard. See you next time. Bye.